Welcome to my projectbazaar.com. Let me discuss about the process epileptic seizure prediction based on multivariate statistical process control of heart rate variability features. Let me discuss about the abstract of the project. The epileptic seizure is a brief episode of signs or symptoms due to abnormal excessive or synchronous neuronal activity in the brain. Seizures can also occur in people who do not have epilepsy for various reasons, including brain trauma, drug use, elevated body temperature, hypoallergeny, and hypoxia. Initially, ECG signal is acquired from dataset, then HRV features are extracted from acquired ECG signals. Here, 8 types of features are analyzed in the HRV analysis section, such as mean NN, SDNN, RMSSD, total power, NN50, LF, HF, and LF bar HF. Heart rate variability is the physiological phenomenon of variation in the time interval between heartbeats. It is measured by the variations in the beat-to-beat interval. After extracted these above mentioned features, multivariate statistical process control, which is an advanced statistical approach which identifies all of the critical variables and underlying patterns in a data set. Process monitoring problems in which several related variables are of interest are collectively known as multivariate statistical process control. Finally, the temporal dynamics of brain activity can be classified into 4 states: inertial, precedential, that is between seizures or baseline and prior to seizure. Seizure forecasting requires the ability to reliably identify a precedential state that can be differentiated from the interictal state. The primary challenge in seizure forecasting is differentiating between the precedential and interictal status. The goal of the competition is to demonstrate the existence and accurate classification of the precedential brain state in walks humans with naturally occurring epilepsy. Let me discuss about the flow diagram for our process. Initially, the EEG signal has been acquired from the dataset, and in the feature extraction, spectrum analysis of EEG frequency bands and analysis heart rate variability of ECG signals are largely used as a biomarker in studying various pathological conditions. Heart rate variability analysis is considered a simple method for investigating neurocardiac regulation. The time intervals between consecutive heartbeats are constantly measured in electroencephalogram from the beginning of a QRS complex to the beginning of the next QRS complex. So these intervals might be called RR intervals, but the conventionally named RR intervals. Many investigators prefer to measure interbeat intervals using a R-wave peak as the reference point, reasoning that it is a measurement can be made with small errors. And in the time domain features, mean NN, mean of RRI, and SDNN, standard deviation of RRI, root mean square of difference of adjacent RRI, total power variance of RRI, and NN50, the number of pairs of adjacent RRI whose difference is more than 50 milliseconds within a given length of measurement time. These are the time domain features. These has been extracted. And in the frequency domain, power of the low frequency band between 0.04 Hz to 0.15 Hz in a PSD. LF reflects both the sympathetic and parasympathetic activity, nervous system activity. And in the HF, power of the high frequency band between 0.15 to 0.4 Hz in a PSD. HF reflects the parasympathetic nervous system activity. And LF or HF, ratio of the LF to HL expresses the balance of the sympathetic nervous system activity with the parasympathetic nervous system activity. And finally, the epileptic seizure detection has been performed by the multivariate statistical process control. Process monitoring problems in which several related variables are of interest are collectively known as multivariate Its statistical process control. Multivariate data analysis is an advanced statistical approach which identifies all of the critical variables and underlying patterns in a dataset. Importantly, it also shows the relationship between the variables and how they impact on each other, essential when trying to understand complex process behavior. Principal component is used to explain the variance covariance structure through a few linear combination of the original variables. Finally, classified it as interictal stage and predictal stage. And after classifying it, we have to analyze the performance. In the performance analysis, HRV analysis, and also predicted episodes. Prediction probability is estimated when changing the number of principal components change. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right-click that file and run for executing this process. Here we analyze the EEG signal. Here only one episodes of EEG signals has been taken. Select any one EEG signal among 30 signals. And after selection of EEG signal, we analyze the performance. After performing all results, I will explain each and every results. And this is the input signal, and this is the RR interval of our input signal. This is the RR intervals between 0 to 4000 beats, and this is the RRI in millisecond by varying the time, and this is the PSD response for our LF and HF, was between power and frequency of hits. Finally, we analyze this EEG signal is predictal stage, and this is the RRI data of EEG of first signal. Here interictal RRI and predictal RRI has been analyzed. This is the RRI data for EEG second signal. This is the RRI data for third EEG signals, and this is the RRI data for fourth EEG signals. Likewise, these 8 signals are performed and we analyze the RRI response. After that, this is the HRV features derived from first EEG signal. Here mean NNN, SDNNN, total power, RMSSD, NN50, LF, HF and LF bar HF ratio has been analyzed. Likewise, this process will perform for entire 8 signals, third signals, and this is the fourth signal result, and this is the fifth signal result, sixth signal, seventh signal, and also eighth signal has been performed. Entire 8 features are extracted. Finally, we analyze the prediction performance when the number of principal components change. By varying the number of principal components, we analyze the predicted episodes between T2 and Q. Finally, we calculate the prediction of seizure, epileptic seizures in our EEG signal. Thank you.